Welcome to this series of lectures on operating systems. Operating systems has always been a favorite with the GATE examiner. Therefore, for any serious GATE aspirant, it can be a game changer. Therefore, pay special attention to the subject operating systems. The topic that we are going to discuss in today's lecture is Introduction to Operating System. Now the first question is, what is an operating system? Now there are various definitions of an operating system, but largely all these definitions can be classified into two major schools of thought. According to the first, an operating system is an interface between the user and the hardware. If this is you and this is the machine, the operating system is somewhere here. Now, if you want to use a machine, it's difficult because the hardware is complex. But the operating system abstracts out the complexity of the hardware and provides you with a user-friendly interface. Hence, the first definition, that an operating system is an interface between the user and the hardware. Now, the other school of thought says that an operating system is a resource manager and allocator. You see, the computer has a number of resources, like you have the CPU cycles, you have the memory, you have disk space. All the applications that you are running on your computer are in fact competing with each other to get hold of these resources. Now there needs to be an arbitrator. The operating system acts as an arbitrator. It manages all the resources of the computer and allocates them to the different applications depending on their requirements. Hence, we can say that an operating system is a resource manager and allocator. Now, let us see what are the operations that an operating system does. Let me first clear the board. What are the functions of an operating system? That is an important question. Now, largely, we can divide the functions of an operating system in a number of groups. Functions of operating system. Now, the first is process management. Now, what is a process? We would come to this topic in details later, but for now, it would suffice to know that the applications that we are running on the computer are nothing but processes. So the first function of the operating system is process management. It is about creating processes, allocating resources to the processes, process synchronization, process scheduling. As you can see, these are the operations under process management that an operating system does. It's about creating processes and also destroying them, allocating resources to the different processes, synchronizing the different processes, and scheduling the different processes, like which process should run first, which process should run second, and so on. The second function of the operating system is memory management. Under this, the operating system keeps track of which part of the memory is being currently used. It allocates and deallocates the memory between the different processes, and it decides in which part of the memory to store which process. Third is secondary storage management. By secondary storage, we mean the disks. The way operating system does memory management, the operating system also does secondary storage management. If there are a number of disks, how to arrange those disks, how to manage the different operations like reading to a disk, writing from a disk, all these operations come under secondary storage management. Now there are many other operations or many other functions that an operating system does, and we would look through them in details during the series of these lectures. But these three are by far the most important: process management, memory management, and secondary storage management, along with input-output management. Okay, so that finishes this part about the functions of an operating system. I will just clear the board for our next topic. Now the next topic is, what are the different kinds of operating system? Kinds of OS. The first in this is a batch operating system. The initial operating systems were batch operating systems. Now the feature about a batch operating system is that a batch operating system can at one time execute only one program. That is, if this is the memory of the machine, the operating system would load only one process at one time. So we can say this is single programming machine. What happened with batch OSs was all the processes that you had to execute, you kept them together serially, and the operating system would take each one of these processes one by one, load them into the memory, execute them, and then take the next process, again load them in the memory, execute them, and this would go on. But the major problem with the batch operating system is it's inefficient. Because at one time, only one program is there in the memory of the computer. The efficiency can be significantly improved if we have a multi-programming system. Multi-programming OS. In a multi-programming OS, the operating system can load multiple number of programs into the memory at one time. Now, what is the advantage that we get out of loading multiple number of programs in the memory? See, every program requires the CPU for some amount of time, and then there is an idle time during which it is doing some input-output operations. Now, when a process is doing input-output operations, it does not require the CPU. Hence, the CPU is idle. If during this time we can use the CPU to execute another process, the efficiency of the CPU would increase. This is precisely the idea behind a multi-programming OS. The multi-programming OS, initially P1 is being executed by the CPU. Say this is the CPU. and P1 is being executed by the CPU. When the P1 now is waiting for some input-output to happen, the operating system can conveniently execute P2 with the CPU. Hence, the CPU is not idle. One major problem with a multi-programming OS is that it is normally not very interactive. By that, what do I mean? Suppose you give 3 programs to the machine to execute. But P1 requires a lot of CPU time. Hence, even though you have given P2 and P3 to execute, they would have to wait for a long time for P1 to release the CPU. Hence, to the user who is running P2 and P3, it would look as if P2 and P3 programs have hanged. That is, the programming environment of the system will not be very interactive. To solve this problem, the third type of OS that has been created is known as a time-sharing OS. In time-sharing OS, if this is the length of the time for which the CPU is executing processes, this time is divided among the different processes. P1, P2, P3, then again P1, and so on. Hence, say initially P1 is being executed by the CPU. After a fixed amount of time T1, even if P1 still requires a CPU, the CPU would be given to P2. Then P2 would execute for say T2 amount of time. After that, the CPU would be allocated to P3. This may execute for T3 amount of time, and then I am back to P1. So in this way, all the processes are getting some amount of time with the CPU, and no process has to wait indefinitely. Now the advantage time-sharing system gives is that this switching between P1, P2, P3 happens so quickly in the computer that to the normal user it would look as if all 3 processes are being simultaneously executed, though actually they are being executed one by one in a schedule. So we have moved from batch operating systems to multi-programming operating systems to time-sharing operating systems. Now, one important topic that is often asked in the GATE examination is the difference between multi-programming and multi-processing. Since a large number of small questions in GATE come from this, let us look into it with further details. If this is your machine, this is your CPU, I would write this as a processor, and this is your memory, then in a multi-programming system, as we have seen, a number of programs are present in the memory at one time. And we have also seen how this increases the efficiency of the processor. This is multi-programming. But in a multi-processing system, you have a number of processors. This is P, PR, this is PR1, PR2, PR3. So the difference is, this is multi-processing. This is the memory, and if it has three processes, P1, P2, P3, it might happen that processor 1 is executing P1, processor 2 is executing P2, processor 3 is executing P3. So the difference is that a multi-processing system is also a multi-programming system, since a number of programs are stored simultaneously in the memory at one time, unless a simple multi-programming system. In a multi-processing system, you have number of processors. See, here, though there are number of processes, there is only one processor, or there is only one CPU. But here, there are multiple programs, okay, but also there are multiple processors. So this is the main difference between multi-programming and multi-processing. A system that is multi-programming can be multi-processing or can be single processing. But a multi-processing system would always be multi-programming. With that, I end this introductory lecture on operating systems. Thank you.